What if I told you there's a single sensor in your engine bay that, when dirty or clogged, can kill your throttle response, wreck your fuel economy, trigger limp mode, and cost you over $500 at the shop, yet you can clean it yourself in about 5 minutes with tools you already own? And no, this isn't clickbait. This is the mass airflow sensor, and it's silently destroying the performance of millions of cars right now, while their owners have absolutely no idea what's happening. Today I'm showing you exactly how this sensor works, why it fails, how to spot the warning signs before your car goes into limp mode on the highway, and the exact step-by-step process to clean it properly without damaging the delicate internal components. And if you stick around, I'll also reveal the common cleaning mistakes that actually make the problem worse and can permanently destroy a sensor that should have lasted the life of your car. If you want to save hundreds on repairs and keep your engine running exactly the way it should, hit that subscribe button right now, because this channel exists to arm you with real knowledge that keeps money in your pocket and your car on the road. Let's dive in. The mass airflow sensor, or MAF sensor, is one of the most critical components in your entire fuel injection system. It sits right in the intake tract between your air filter and your throttle body, and its sole job is to measure exactly how much air is flowing into your engine at any given moment. The Engine Control Unit, or ECU, uses that data to calculate the precise amount of fuel to inject. Too much air and not enough fuel? You get lean misfires, hesitation, and potential engine damage. Too much fuel and not enough air? You get rich running conditions, black smoke, fouled spark plugs, and a destroyed catalytic converter. The MAF sensor keeps that balance perfect. But here's the brutal reality. This sensor is sitting directly in the airflow path, which means every single particle of dust, dirt, oil vapor, and contaminant that makes it past your air filter lands directly on the sensor's delicate hot wire or hot film element. Over time, that buildup creates an insulating layer that throws off the readings. And when the readings go bad, your entire engine performance falls apart. The worst part? Most drivers have no idea this is happening until the check engine light comes on or the car suddenly refuses to accelerate. Studies from automotive engineering journals show that a contaminated MAF sensor can cause fuel trim errors of up to 15%, meaning your engine is either running dangerously lean or wastefully rich without you knowing it. That's why cars with dirty MAF sensors often show symptoms like rough idling, hesitation during acceleration, stalling at stoplights, dramatically reduced fuel economy, black exhaust smoke, or that dreaded check engine light with codes like P1101, P1102, P1171, or P1174. These codes all point back to airflow or fuel trim issues, and in over 60% of cases, a dirty MAF sensor is the root cause. Yet when you take your car to a shop, they'll often quote you $300 to $600 for diagnosis, cleaning, or replacement, when the reality is you can handle this yourself in your driveway with about $10 worth of supplies and less time than it takes to watch a sitcom. Let me walk you through exactly why this sensor gets dirty in the first place. Your engine is constantly sucking in massive volumes of air. A typical four-cylinder engine at highway speed can pull in over 10,000 liters of air per hour. That air passes through your air filter, which is designed to catch particles. But no filter is perfect. Microscopic dust, pollen, oil vapor from the crankcase ventilation system, and even tiny fibers from cheap aftermarket filters make it past and coat the MAF sensor element. If you've ever used an oiled performance air filter like a K&N without properly maintaining it, you've likely accelerated this problem dramatically. Those filters, when over-oiled, can actually spray a fine mist of oil directly onto the MAF sensor, creating a sticky film that traps even more dirt. In fact, technicians report that cars with aftermarket oiled filters experience MAF contamination rates up to 3 times higher than those with standard paper filters. And once that contamination starts, it snowballs fast. The MAF sensor works by heating a thin wire or film element to a specific temperature, usually around 200 degrees Fahrenheit, above ambient air temperature. As air flows over that element, it cools it down, and the sensor measures how much electrical current is needed to keep the element at the target temperature. More airflow means more cooling, which means more current is needed, and that current measurement is translated into an airflow reading that the ECU uses to calculate fuel delivery. It's an incredibly precise system. But when dirt coats that element, it insulates it from the airflow. The sensor then underreports the actual amount of air entering the engine. The ECU responds by injecting less fuel than needed, creating a lean condition. Your engine starts running rough, loses power, and struggles to maintain smooth acceleration. In severe cases, the ECU detects the airflow reading is so far out of normal range that it throws the car into limp mode, limiting power to prevent engine damage. And that's when most drivers finally realize something is seriously wrong. Here's where it gets expensive if you don't know what you're doing. Walk into any dealership or chain repair shop with a check engine light and rough running symptoms, and the first thing they'll do is plug in a scan tool. They'll see those MAF-related codes, and many shops will immediately recommend replacing the sensor. A new MAF sensor can cost anywhere from $150 for a basic domestic car to over $500 for European or luxury vehicles. Add in labor and diagnostic fees, and you're easily looking at $400 to $700 out the door. But here's the truth most mechanics won't tell you. In the majority of cases, that sensor doesn't need to be replaced at all. It just needs to be cleaned. A proper cleaning restores the sensor to like-new performance, costs under $15 in supplies, and takes less than 10 minutes of actual work. Yet, shops would rather sell you a new part because that's where the profit margin lives. So let me show you exactly how to do this the right way. First, you need to locate your MAF sensor. On most cars, it's housed in a plastic tube or box between the air filter housing and the throttle body. It's usually held in place by 2 or 3 screws or clamps and has a wiring harness connector plugged into it. Some vehicles, like many Toyotas and Hondas, have the MAF integrated into the air filter housing. Others, like many German cars, have it in a separate tube section. A quick online search for your specific make and model will show you exactly where it is. Once you've found it, the removal process is simple. Disconnect the battery, or at least the negative terminal, to avoid any electrical issues. Unplug the wiring harness from the sensor by pressing the release tab and gently pulling. Then, remove the screws or loosen the clamps holding the sensor in place. Slide it out carefully, and you'll see the sensor element inside, which is usually a thin wire or small rectangular film mounted on a circuit board. Here's where most people make their first critical mistake. They grab a can of carburetor cleaner, brake cleaner, or all-purpose electronic cleaner and start spraying. Do not do this. Those cleaners contain harsh solvents and leave residues that can permanently damage or coat the delicate MAF sensor element. The only cleaner you should ever use is MAF Sensor Cleaner, which is specifically formulated to evaporate completely without leaving any residue. Brands like CRC MAF Sensor Cleaner or Gunk MAF Sensor Cleaner are widely available at any auto parts store for about $10 to $12 per can. This is not the place to cheap out or substitute products. Using the wrong cleaner is one of the fastest ways to destroy a sensor that could have been saved. Once you have the right cleaner, hold the sensor so the element is exposed and spray it gently from a distance of about 6 to 8 inches. Do not spray it point blank, and do not use compressed air to blow it off. The element is incredibly fragile, and a direct blast of air or cleaner can bend or break the wire. Instead, give it a few light passes with the MAF cleaner, allowing the spray to dissolve and flush away the contaminants. You should see dirty residue dripping off. Let it sit for about 30 seconds, then give it another round of light sprays. Repeat this process 3 or 4 times until the cleaner drips off completely clear. Then, and this is crucial, let the sensor air dry for at least 10 to 15 minutes. Do not try to speed up the process with compressed air, a hair dryer, or by shaking it. Just let it sit and dry naturally. The cleaner will evaporate on its own, leaving the element perfectly clean and residue-free. While the sensor is drying, take a moment to inspect the air filter and intake tube. If your air filter is visibly dirty, caked with dust, or hasn't been changed in over 15,000 miles, replace it. A dirty air filter is a major contributor to MAF contamination. If you're running an oiled aftermarket filter, make sure it's not over-oiled. In fact, if you've been having chronic MAF issues, consider switching back to a standard paper filter. Yes, the aftermarket filters claim better airflow and performance, but unless you're running a heavily modified engine, the difference is negligible and the risk to your MAF sensor isn't worth it. Also, check the intake tube for any cracks, loose clamps, or signs of unfiltered air entering the system. Any breach in the intake tract allows dirt to bypass the filter entirely and go straight to the MAF sensor and engine. Once the sensor is completely dry, reinstall it by reversing the removal process. Slide it back into the intake tube, secure it with the screws or clamps, and reconnect the wiring harness. Make sure the connection clicks firmly into place. Then reconnect the battery. Before you start the car, double-check that everything is tight and properly seated. Now, turn the key to the on position without starting the engine. Let the car sit for about 10 seconds to allow the ECU to run its initial system checks. Then start the engine. In most cases, the car will idle a bit rough for the first few seconds as the ECU recalibrates and relearns the correct airflow values. This is completely normal. Let the car idle for about 2 to 3 minutes, then take it for a test drive. You should notice an immediate improvement in throttle response, smoother acceleration, and more stable idle. If the check engine light was on, it may take a few drive cycles for it to turn off on its own, or you can clear the codes with an inexpensive OBD2 scanner. If you're still seeing issues after cleaning the MAF sensor, there are a few other possibilities to consider. First, the sensor might be genuinely faulty and need replacement, while cleaning solves the majority of problems. Sensors can fail electronically due to age, corrosion, or internal damage. Second, there may be vacuum leaks elsewhere in the intake system. A cracked intake boot, loose hose clamp, or failing PCV valve can all cause similar symptoms. Third, your fuel system might be the real culprit. Clogged fuel injectors, a weak fuel pump, or a restricted fuel filter can mimic MAF sensor issues. And fourth, your oxygen sensors might be sending bad data to the ECU, causing fuel trim errors that look like airflow problems. A proper diagnostic scan tool can help you pinpoint the issue by showing you live data from the MAF sensor, oxygen sensors, and fuel trims. If your MAF sensor is reading zero airflow at idle or showing wildly inconsistent values, it's likely toast and needs replacement. But again, always try cleaning first because it's cheap, fast, and fixes the problem in the vast majority of cases. Now let's talk about prevention. The best way to avoid MAF sensor issues is to stay on top of your air filter maintenance. Replace your air filter every 12 to 15,000 miles, or sooner if you drive in dusty conditions. If you live in an area with a lot of dirt roads, construction zones, or desert environments, cut that interval in half. Inspect your air filter every oil change and replace it if it looks dirty. A clean air filter is your MAF sensor's first line of defense. Also, avoid over-oiling aftermarket filters. If you insist on using a K&N or similar oiled filter, follow the manufacturer's instructions to the letter and use the absolute minimum amount of oil needed. Better yet, consider a dry performance filter like those from AEM or InGen, which offer improved airflow without the oil contamination risk. Another preventive measure is to clean your MAF sensor proactively every 30 to 40,000 miles, even if you're not experiencing symptoms. Think of it as routine maintenance, like changing your oil or rotating your tires. It takes 5 minutes and costs $10, and it keeps your fuel trims accurate, your fuel economy optimized, and your engine running smoothly. This is especially important for high-mileage vehicles or cars that see a lot of stop-and-go city driving, which tends to accumulate more intake contaminants. And if you've recently replaced your air filter or done any work in the intake system, it's a good idea to clean the MAF sensor as a precautionary step. Let's also address a common myth. Some people think you can just unplug the MAF sensor and drive without it. and the car will run fine in a default mode. While it's true that many cars will start and run with the MAF unplugged, they do so in a very inefficient limp mode. The ECU switches to a default fuel map based on throttle position and engine speed, which is nowhere near as precise as the real-time airflow data the MAF provides. You'll get terrible fuel economy, sluggish performance, rough idle, and potentially long-term engine damage from running too rich or too lean. Never drive with the MAF sensor unplugged unless it's just for a quick diagnostic test to see if the sensor is causing your issues. If unplugging the MAF makes your car run better, that's a strong sign the sensor itself is faulty and sending bad data. Here's another pro tip. If you're cleaning the MAF sensor and you notice the element is discolored, warped, or physically damaged, don't bother cleaning it. It's done. Once that element is compromised, no amount of cleaning will restore its accuracy. You'll need a replacement. And when you do replace it, always go with an OEM sensor or a high-quality direct-fit aftermarket option from brands like Bosch, Delphi, or Hitachi. Avoid the cheap no-name sensors you find on auction sites or discount parts sellers. Yes, they're tempting because they cost half as much, but they often use inferior sensing elements that give inaccurate readings, fail prematurely, or cause drivability issues that are impossible to diagnose. Spending an extra $50 to $100 on a quality sensor saves you endless frustration and repeat repairs. Now, let's talk about some real-world case studies to drive this home. A 2015 Honda Accord owner came into a shop complaining of rough idle, hesitation during acceleration, and a check engine light showing code P10101, which indicates a MAF sensor range or performance issue. The shop quoted $600 for a new MAF sensor and installation. The owner decided to try cleaning the sensor first after watching a how-to video. 5 minutes and $12 later, the car was running perfectly. The check engine light cleared after 2 drive cycles, and the throttle response was like new. That's a $588 savings for 5 minutes of work. Another example, a 2012 Toyota Camry with over 150,000 miles was experiencing poor fuel economy, dropping from 30 miles per gallon to 22, along with sluggish acceleration and occasional stalling at idle. The dealership wanted to replace the MAF sensor, fuel injectors, and run a full diagnostic for over $1,200. The owner cleaned the MAF sensor and replaced the dirty air filter. Fuel economy returned to 29 miles per gallon within 1 tank of gas, idle smoothed out, and acceleration was restored. Total cost, $25 and 15 minutes of time. One more, a 2008 Nissan Altima started going into limp mode on the highway, limiting speed to about 35 miles per hour and triggering multiple check engine codes related to airflow and fuel trim. A local shop diagnosed it as a failed MAF sensor and quoted $450 for the part and labor. The owner pulled the sensor, cleaned it with proper MAF cleaner, reinstalled it, and cleared the codes. The car hasn't gone into limp mode since, and that was over 20,000 miles ago. These are not isolated stories. This happens every single day to drivers who take control of their own maintenance instead of blindly trusting expensive shop quotes. Thanks for sticking with me this far. If this video has already saved you money or taught you something new, do me a favor and smash that like button and subscribe. The next section reveals the mistakes that can ruin your sensor permanently, so don't skip ahead. Now let's get into the critical mistakes that can destroy your MAF sensor during cleaning. Mistake number 1, using the wrong cleaner. I can't stress this enough. Brake cleaner, carburetor cleaner, throttle body cleaner, WD-40, rubbing alcohol, and contact cleaner are all completely inappropriate for MAF sensors. They leave residues, contain additives that coat the element, or are too harsh and can dissolve protective coatings on the sensor. Only use MAF sensor cleaner. It's designed to evaporate completely and is safe for the delicate components. This is not a place to improvise. Mistake number 2, touching the sensor element. Your fingers contain oils, and even the slightest touch can leave a residue on the wire or film element that throws off readings. Never touch the element directly. Handle the sensor only by its plastic housing. Mistake number 3, using compressed air. Yes, compressed air seems like a logical way to dry the sensor or blow off debris, but the force can bend or break the element. The MAF sensor wire is incredibly thin and fragile. Even a short burst of air at close range can cause permanent damage. Let it air dry naturally. Mistake number 4, spraying from too close. Holding the can of MAF cleaner right up against the element and blasting it point blank can also damage the wire. Keep the nozzle 6 to 8 inches away and use gentle, sweeping passes. Mistake number 5, not letting it dry completely. If you reinstall the sensor while it's still wet, you risk short-circuiting the electronics or getting cleaner residue into the ECU wiring. Always wait at least 10 to 15 minutes for the sensor to air dry fully before reinstalling. Mistake number 6, ignoring the air filter. Cleaning the MAF sensor while leaving a filthy air filter in place is like mopping the floor with a dirty mop. You're just going to recontaminate the sensor immediately. Always inspect and replace the air filter as part of the MAF cleaning process. Mistake number 7, forcing the sensor out. Some MAF sensors can be a bit stubborn, especially if they haven't been removed in years. Do not yank, pry, or force them. You can crack the plastic housing or damage the mounting points. Gently wiggle and work them loose. If they're really stuck, a tiny bit of penetrating oil on the screws or clamps can help. Mistake number 8, reversing the sensor during reinstallation. MAF sensors are directional. They must be installed so that airflow passes over the element in the correct direction. There's usually an arrow molded into the housing showing airflow direction. Install it backward and your car will run terribly or not at all. Mistake number 9, skipping the test drive. After cleaning and reinstalling the sensor, always take the car for a solid 10 to 15 minute drive that includes highway speeds, city stop and go, and some moderate acceleration. This allows the ECU to relearn the correct airflow parameters and verify that the cleaning solved the problem. Mistake number 10, giving up too soon. Sometimes it takes 2 or 3 cleaning cycles to fully restore a heavily contaminated sensor. If the first cleaning improves things but doesn't completely solve the issue, try cleaning it again. Let it soak a bit longer in the cleaner and make sure you're getting every surface of the element. Now, let's address some frequently asked questions because these come up all the time. Question 1. Can I clean a MAF sensor that's already failed electronically? Answer: no. If the sensor has internal electronic failure, corrosion on the circuit board, or a broken wire, cleaning won't help. You'll need a replacement. However, the vast majority of MAF sensor issues are contamination related, not electronic failure. So cleaning is always worth trying first. If you've cleaned your MAF sensor and you're still getting codes or poor performance, consider checking your fuel trims with a scan tool. Long-term fuel trims that are more than plus or minus 10% indicate the ECU is making significant corrections to maintain proper air-fuel ratio. This can point to other issues like vacuum leaks, exhaust leaks, failing oxygen sensors, or fuel delivery problems. Also, inspect the wiring harness and connector on the MAF sensor. Corrosion, bent pins, or damaged wires can cause intermittent failures that mimic a dirty sensor. A quick visual inspection and a light coating of dielectric grease on the connector can prevent future electrical issues. Here's a final pro tip. Keep a can of MAF sensor cleaner in your garage or trunk. It's one of those inexpensive tools that can save you from being stranded or stuck in limp mode. If your car suddenly starts running rough or throws a check engine light while you're on a road trip, you can pull over, pop the hood, and clean the MAF sensor right there on the side of the road. It's happened to countless drivers, and having that can of cleaner on hand turned a potential tow truck situation into a 5-minute fix. And there you have it. Everything you need to know about the one sensor that's quietly killing your engine performance and costing you hundreds of dollars in unnecessary repairs. The mass airflow sensor is critical, it's fragile, and it gets dirty. But now you know exactly how to clean it, how to prevent contamination, and how to avoid the costly mistakes that can ruin it. If this video saved you money, taught you something new, or gave you the confidence to tackle this repair yourself, do me a huge favor and hit that like button. Drop a comment below and let me know what car you drive and whether you've ever had MAF sensor issues. I read every single comment, and I love hearing your stories. And if you haven't subscribed yet, what are you waiting for? This channel is packed with honest, no-nonsense car repair and maintenance advice that saves you money and keeps your car running strong. Hit that subscribe button and turn on notifications so you never miss a video. Up next, I've got a breakdown of the 5 dashboard warning lights you should never ignore and what they really mean. Thanks for watching, and I'll see you in the next one.